Hello, this is Mr. Varero, and I'm going to be talking you through the last of the inferential tests called chi-square. And this is something which I often have taught in the first context of looking at inferential tests, but I've kind of left it until later because of just people's misunderstanding of nominal data, or the data is at a level of measurement of nominal. And so, of course, we are checking that every parameter is ultimately there. And of course, if it was stronger, we would be testing for a relationship. So we see that the other reason why we're looking at chi-squared is because of this word association. And you'll find that mathematically, it's not a very strong mathematical kind of relationship between the data, and so that we do look for an association here to see if there is something in it. And of course, the other reason they say is that we're testing a difference. So kind of look out that you have clearly got nominal data, and you also they use the keyword association. And I suppose it all starts that when we looked at features of science, we saw that hypothesis testing was a really important aspect of science, or feature of science, where we could test kind of phenomena, and of course we can test the most bizarre ideas. And sometimes, of course, things are quite straightforward, and therefore some of the other tests kind of seem more appropriate. But I'm just going to show you an idea that potentially might be more difficult to kind of have a look at. So it says here that, and it probably comes from an observation that people potentially have, and it says here, people who believe. Okay, so you can see either you don't believe, or you do believe. You can see kind of where the nominal data is coming in there. And maybe there's this observation that some people appear to be better at kind of getting a chance question right. A chance question right is what number will I throw, or what card am I going to pick, and things like that. So moving this forward to the chi-squared test, and just something I have to just point out to you as well, is that it has a specific symbol. It's actually meant to be a more kind of curved X, and the one question that I did have in the legacy paper actually had that symbol visible to you. So just look out for kind of subtle hints like that, that it could be a chi-squared test. So let's just look at an example of a hypothesis. Okay, so this is a hypothesis. It says belief in the paranormal is significantly associated with a correct assessment of chance. And of course, we have the key word there, associated. And we see that if I dig deeper in terms of what this hypothesis means, we see that, first of all, that you either have a category of belief or not belief. Okay, so it's kind of like a 0 and a 1. And the second category we have is the right or wrong. Once again, 0 or 1. So if I was looking at this, I could potentially kind of start looking at this idea that this is going to be a nominal data type of example. And so therefore, I will forget about everything else and turn straight to the chi-squared. It happens to be non-directional because I'm not saying that you will be better at the chance assessment or worse at it. So I'm just saying there is something there. And you're probably also familiar with looking at a table like this. Now, in year 12, I told you about contingency tables because it's one of the few tables that they can ask you to do. So, for example, in this particular context, if we know that 17 people got the activity right and 5 of them had a belief, then we can make up the numbers up to 17 and say that there's 12. So it's one of the tables I can ask you to draw. Now, the totals are there for the calculation, and nothing else, because what is important are the categories. So we have belief and non-belief, so there's 2 categories there, and right and wrong. So this ends up being a 2-by-2 table. Okay, and I suppose what we can read from this is that, for example, 10 people had a belief in the paranormal and got the activity wrong. Okay, the chance activity wrong. Now, it's not restricted to chi-squared of 2-by-2s. There's other tables we can potentially have, and we'll see that this is one of the few kind of so-called normal inferential tests that you would have done, that are not the unrelated or related t-tests, that uses degrees of freedom in order to kind of work out your critical value. And that will just be dependent on the 2-by-2 table. Now, if you do biology, chi-squared is also part of of that, and they kind of work things slightly differently because I'm kind of paring this down to a kind of simple nominal data type of example. Okay, so there is a formula that works out the observed value. And in this particular case, we see that the chi-squared value equals 1.948. Okay, and of course, I'm kind of once again repeating this idea that you can use the observed value or the calculated value to refer to this, but it will be done for us. Okay, and so therefore we need to look at the critical values. Now, this is actually something which in the old spec they did ask you to kind of know the formula of degrees of freedom in this particular case. So it happens to be the number of rows, take away 1, multiplied by the number of columns, take away 1. But I still feel that this is going to be too complicated for them to kind of ask you to solve. And so they'll probably ask you to substitute in for it. Or, as you'll see when you look at the legacy papers, the only question that they've ever had this, they actually only gave you a critical value where the degree of freedom was 1, because it was a 2 by 2 table. And so there we have the similar example of what we've seen previously with the unrelated and related t-tests in terms of a table that has degrees of freedom and the different particular values that we have. Now, what we can tell is based on the information we have about this particular hypothesis, we're testing it at 5%, it's a two-tailed, and there was 1 degree of freedom, and so therefore the critical value is 3.84. And following the same kind of process as we've done before, it says the observed value, which was 1. Can't remember it offhand, 1.948, it needs to be equal to or greater than 3.84. And in this case, that's obviously not true. And so therefore, it's insignificant. And I suppose that would make sense. I'm looking for that association, but of course, clearly, just believing in something doesn't mean that you're better at it, or that you have a particular ability to be able to predict what card's going to come out of a pack of cards and things like that. So the last thing we have to do once we have that particular situation is to decide what we're going to do. So we reject the hypothesis and we kind of claim that there isn't an association between paranormal belief and a correct assessment of chance or coincidence. And so therefore, I don't feel chi-squared is any different to any of the other inferential tests other than spotting that it is chi-squared, and that's through the nominal data. And these ones shouldn't be that difficult to do. We see 1 degree of freedom directional, 2.84, so 2.84 and 2.71. We see that the first one is not significant because it needs to be 2.81 needs to, oh, actually, I am incorrect there. It is significant. Read the statement. The observed value of 2.81 needs to be equal to or exceed the critical value. So therefore, it is significant. For the second one, we have degrees of freedom of 4, and we have two-tailed, so that's 9.49. So 9.21 is not bigger than 9.49, so that one's not significant. Let's have a look at the next one, 4.99. It says 2 degrees of freedom. Okay, this is just a reminder that it does say equal, and so therefore that's fine. So that's going to be significant. The second one, let's go have a look, one tail, 4.60. Yeah, and also take the numbers at face value. Even though I could round that up to 4.66, 4.6, it's not the same, so therefore it is not significant. Now, I know I've rushed through all these types of examples myself. Please check that you can do them. Check that you can actually see whether it is significant or not, because that's going to be important to you. Okay. So chi-squared, not meant to be challenging. The hardest part, obviously, is spotting that it is chi-squared. And so in this particular example, I have another chance to have a look at it. And we see a hypothesis here. It says, certain parental styles are associated with greater turmoil in adolescence. Now, at first, you might not spot kind of what the nominal data is here, but we see it has the word associated. And there's no other place that we're going to do this, okay? So so perhaps as the study goes on, we'll be able to determine whether it is nominal or not. And if we look at some of the categories that we have, we see that their contingency table in this particular case gives a category for parental style of only 3 types: authoritarian, democratic, and laissez-faire. Laissez-faire is kind of easygoing. Authoritarian, we did that in year 12. And of course, democratic. Probably not the best style, but you never know. And other categories is either you have high or low turmoil. Okay, so even though it might not be obvious at this particular stage, we see that the word association has given us that hint, and then when we break down the parental style, break down turmoil, we see that it is actually nominal data. This could be a table associated with that. That's another key way. If they show us a contingency table in this particular case, then we know that it must be a chi-squared. And we see here we have an observed value of 4.04. Okay, we see that we go back to our table here, and we have a two-tailed with 2 degrees of freedom is giving me a critical value of 5.99, and unfortunately, once again, there's no association between parental style and adolescence. So if you can't do this, please kind of have a check that you can, and that you can ultimately do it. We see that it's not a popular question, but this was part of a 12-mark kind of question. So it's really important that you do have a look at this, and there's an experimental design in there, and there's a few other things that you can practice with quite nicely in. Now that's chi-squared. Just to finish with, I just wanted to reinforce some of the ideas that are not directly examinable, but are kind of part of our choice of which test we should do. The parametric versus non-parametric, we see that if you have nominal or ordinal data, okay, then we use non-parametric tests, so that's your Wilcox and Mann-Whitney-Spearmans. If you are using interval or ratio data, well, I didn't mention ratio to you, but it's very similar to interval, we do your related, unrelated, and Pearson's test. And also, of course, if we have a normal distribution, we tend to also use a kind of parametric test in this particular case. And with the parametric tests, we use degrees of freedom rather than kind of number of participants, but we see that there's a kind of a set of formulas that you kind of work on. I wouldn't say that you will need to do this, especially even before they mentioned kind of that there's going to be a change in exams, that they would offer formula sheets anyway. So there's a good chance that you wouldn't be expected to do this in the first place. So there we go. We've finished all the tests. I hope that you find it kind of reasonable, and we'll take it from there. Okay, goodbye.